All right, if we're doing composite functions where the inverse function's on the inside, what you want to do is first realize that this thing inside of here, inverse tan of 4, for example, that's an angle. So the way I would do this problem is I would say let theta equal inverse tan of 4. And now I'm supposed to find the sine of this. Well, I'm going to have to draw a triangle to work this out. So this is inverse tan of 4. And I'm just going to draw a triangle, just a right triangle here. So here's theta. And if theta is the inverse tan of 4, what that means is tan of theta is 4. And you think of that as the opposite over adjacent. That makes the third side of this thing square root of 13. So now we can just read the sine of theta. This right here is equal to sine of theta. And sine of theta is going to be opposite over adjacent. So 4 over root 13, or 4 root 13 over 13. All right, this next one, we've got a negative number here. So we need to be a little bit careful here. On the first one, it was a positive number, and so I just assumed that it was a first quadrant angle, and I didn't worry about the signs of anything. But here we're looking at inverse sine of negative 3/4. So I'm going to let theta equal inverse sine of negative 3/4. And on this one, I'm going to draw it like this. If theta is inverse sine of a negative number, theta is in quadrant 4. So I'm going to do this, and if this is, it's like theta is this angle. This is my reference angle here. So the sine of theta then is negative 3/4. So that means the opposite is negative 3, and the hypotenuse is 4. So what's that make the other side? Don't trip up and say it's a 3, 4, 5 triangle, because that only happens when you have 3 and 4 on the legs. On this one, the 4 is on the hypotenuse. So the other side is going to be, let's see, a squared plus 3 squared equals 4 squared. So a squared is going to be 7, so this is square root of 7. So from there, we should be able to fill out what the cosine of this angle is. The cosine of the angle is, well, I can't really write an intermediate step here. The cosine of the angle here is going to be the adjacent over the hypotenuse. Adjacent over hypotenuse, so we get root 7 over 4. Now, should it be positive or negative? Well, it's in quadrant 4, and we're looking at a cosine. So quadrant 4, cosine is positive. Really, that sort of takes care of itself if we are careful about labeling these as being positive or negative. Let's do another one. Cosine of inverse sine of minus 5 over 13. So first up, theta is inverse sine of negative 5 over 13. Now, again, this is in quadrant 4. And we get sine of theta is negative 5 over 13. So if I draw this into quadrant 4, that's my reference angle. So the opposite is 5, or negative 5, and the hypotenuse is 13. If you solve that out, it makes this side over here 12. Yeah. So what I get here is the cosine of this angle is going to be the adjacent over the hypotenuse, which is 12 over 13. All right, let's look at this one. Cosine of inverse tan of 5. All right, so theta is inverse tan of 5. Tan theta then is 5 over 1. But let's see, which quadrant are we in? We're in quadrant 1. So the opposite is 5. The adjacent is 1. The other side, let's see, 5 squared is 25. 1 squared is 1. So this side is root 26. We're supposed to do the cosine of this. So cosine of theta is going to be 1 over root 26. Or that. All right. Sine of inverse cosine of negative 2/3. So you let theta equal inverse cosine of negative 2/3. All right, cosine's negative, so that means we're in quadrant 2. So let's see, cosine of theta is minus 2/3. So I'm going to draw this out in quadrant 2. The opposite is 2. The adjacent, or no, cosine is adjacent over hypotenuse. So the adjacent side is negative 2 and the hypotenuse is 3. Keep in mind, hypotenuse is always positive. So let's see, what's this other side? Well, this other side is, let's see, negative 2 squared plus b squared equals 3 squared. So what have we got? B squared plus 4 equals 9. So b squared is root 5, plus or minus. And it's going to be positive because of this quadrant. So we're supposed to find the sine of theta. Sine is opposite over adjacent. I'm sorry, opposite over hypotenuse. And that's our answer. All right, and that appears to be the end of this section.